Hello, my dear students. I have already discussed about infiltration index in the last class. It is the average rate of loss such that the volume of rainfall in excess of that rate will be equal to the direct runoff. Mainly, there are two types of infiltration indices. The first one is W index and second one is phi index. The phi index is defined as the average rate of rainfall above which the rainfall volume equal to the runoff volume. Means it is the average rate of rainfall above which the rainfall volume is equal to the runoff volume. It can therefore be defined as the average rate loss such that the volume of rainfall in excess of that rate will be equal to the volume of direct runoff. The runoff volume above phi index is usually known as rainfall excess or effective rainfall. So this effective rainfall or this runoff is given by summation of I minus phi into T. Okay, so here R is runoff, P is I is precipitation, and phi is phi index, and T is time in hours. Okay, next W index. This index gives the average rate of infiltration for that time period of the storm rainfall during which rainfall intensity is greater than W. Okay, thus it can be said to be refinement over phi index, which apart from infiltration also includes interception and depression storage. It is given by this formula P minus R divided by T, where P is precipitation, R is runoff, and I is surface retention, T is time. Okay, always W index is less than phi index. You have to remember this while solving the numericals. Let us solve some numericals related to this. The first one is the rainfall rates for successive 30 minutes intervals up to 4 hours are given below. If the surface runoff is 3.6 centimeter, determine phi and W indexes. Okay, so here you have to calculate what is W index and what is phi index. Okay, the rainfall rates are given here, intensity is given for every 30 minutes. Okay, up to 4 hours, and surface runoff is given. So, what we have to calculate first? We have in a formula W is equal to P minus R minus I divided by T. Here we require P. What is P? Precipitation. R we have runoff and I is not required here. Surface retention value is not there. So usually we use W index is equal to P minus R divided by T. Okay, let us calculate first precipitation. What is that precipitation? It is given here, rainfall intensity for every 30 minutes. It is 1.3 plus 2.8 plus 4.1 plus 3.9 plus 2.8 plus 2 plus 1.8 plus 0.9. Okay, this is for 13 centimeter per hour. Okay, so here it is given for 30 minutes. So convert into hour. So 30 divided by 60. Okay, so you have to convert into hour. This is in minutes. Every 30 minutes, you can see here 0 to 30, 30 to 60 minutes, 60, 90 minutes, 120 minutes. So convert into per hour. So that becomes 30 divided by 60. So here we will get 9.8 centimeter. Okay, precipitation is equal to 9.8 centimeter. So while this is in centimeter per hour, so divided by R, multiplied by R, so that per hour get cancelled. So the remaining is 9.8 centimeter. Okay, so we know now P. We have R. It is given, that is equal to 3.6 centimeter, and I is equal to 0. So substitute in this equation. W is equal to P minus R minus I divided by T. What is P? P is 9.8 centimeter and R is given 3.6 centimeter minus 0 divided by that T is, that is intervals up to 4 hours it is given, so that is 4. So simplify, calculate, you will get 1.55 centimeter per hour, W index. Okay, now W index is 1.5 centimeter per hour. W index is always less than 5 index. 5 index. Okay. So what we have to do? Assume 5 index to be greater than 1.55 centimeter per hour, because W index is less than 5 index. We have this formula: total runoff, that is equal to, R is equal to summation of I minus phi into T. Okay, now I is the precipitation and phi index, R is total runoff, T is the time. Okay, now total runoff, R is, we know, that is 3.6 centimeter equal to I. Now here what you have to consider, the precipitation greater than 1.55 centimeters should be considered, because W index is less than 5. So we cannot consider the value less than 1.55 centimeter. What happens if we consider, suppose now this is the first precipitation, I 1.3. So what is that? I is equal to, suppose 1.3 minus this 1.55, then it becomes negative value. So always we have to consider the phi value which is greater than the W value. Okay, so now W is 1.55. So whatever the I value less than 1.55 should not be considered, only greater than 1.55 should be considered. So now first one is 1.3. So it is less than 1.55. So we cannot consider that. Here this is the summation. So let us consider all in separate intensities. I minus Q. This means I1 minus, not Q5, I1 minus 5 plus I2 minus 5 plus I3 5, like that summation. No, so you have to consider separately. So 1.3 you cannot consider. So let us take 2.8. I is equal to 2.8 minus 5. 5 we don't know, we have to calculate. Plus, next I value is 4.1. So 4.1 minus 5. Plus, next value is 3.9 minus 5. Plus 2.8 minus 5. Plus 2 minus 5. Plus 1.8 minus 5. This 0.9 we cannot consider because it is less than 1.55. So only this many into, this is you have to convert into hour. So this is 30 centimeters. I mean it is 30 minutes intervals, convert into hour. So 30 divided by 60. 1 hour is equal to 60 minutes. So convert into hour. So 30 divided by 60. So we have this 3.6. Substitute this 5 value goes this side. What you have to do, 2.8 plus 4.1 plus 3.9 plus 2.8 plus 2 plus 1.8 minus 5, 5, 5. Add all the 5s. 1, 2, 3, 4, 5, 6 5s. So minus 6, 5, that is equal to 3.6. So 6, 5 is equal to, whatever you add, you get the answer minus 3.6 into 30 divided by 60. So you will get only one unknown, that is 5. 5 is equal to 1.7 centimeter per hour. Okay, like this you have to calculate W index and phi index. W index, we have formula P minus R minus I divided by T. We have to calculate P. P is nothing but precipitation. Take the sum of all the precipitation intensity value and convert into R. Okay, this is given 30 minutes. So 30 divided by 60 becomes R. So calculate P. R is given, I is not required, and T is the total duration, that is for us. Once if you get W, you can calculate phi. How? We have this formula, R is equal to summation of I minus phi into T. Okay, substituting this kit, you will get what is phi. I hope all of you understood. Let us take one more example. Take this, the rate of rainfall for successive 30 minutes periods of a 4-hour storm are as follows: 3.5, 6.5, 8.5, 7.8, 6.4, 4, 4, 6 centimeter per hour. Taking a value of phi index as 4.5 centimeter per hour, compute the total rainfall excess and W index. W index is also you can write WI. So three these terms we have to calculate: the total rainfall excess and W index. So how we can calculate total rainfall? It is given here all the rainfall intensities. So just add that. That is 3.5 plus 6.5 plus 8.5 plus 7.8 plus 6.4 plus 4 plus 4 plus 6 into, again it is in centimeter per hour. I mean it is given in 30 minutes intervals. So convert into hour. So into 30 divided by 60. So we will get precipitation is equal to 23.35 centimeters. So second one is we have to calculate total rainfall excess. That is nothing but runoff. Okay. So runoff we have formula summation of I minus 5 into T. Okay, now we have phi value that is given here. Taking the value of phi index is given, that is 4.5 centimeter per hour. Since phi is equal to 4.5 centimeter per hour, rainfall intensity less than 4.5 centimeter per hour should not consider, because W is less than phi. Okay, so we have to consider the value which is greater than 4.5 centimeter. It is given here phi index. Okay, always W index is less than 5, so we have to consider the more than 4.5 centimeter value. So how we will calculate total rainfall excess or runoff, that is equal to summation of I minus 5 into T. I is what? First one 3.5, but 3.5 that is less than 4.5. So we cannot consider. If we consider, that term becomes 0. Anyhow it is not valid. Next one is 6.5. 6.5 minus 5. 5 is given 4.5 into T, that we will consider at the end, plus again second I is 8.5 minus 4.5 plus 7.8 minus 4.5 plus 6.4 minus 4.5 plus 4. Again we cannot consider this 4, because the value less than 4.5 centimeter per hour we cannot consider. So this 4 will not be there. So next is 6. Last one, 6 minus 4.5 into 30 divided by 60 time duration, that is 30 minutes per hour. 30 minutes, so convert into hour. 30 divided by 60. So we will get surface runoff is equal to 6.35 centimeter. Now we know what is P and what is R. So we can calculate W index. We have formula W is equal to P minus R divided by T. What is P? P is 23.35 minus R is 6.35 divided by time. Time is 4 hours storm. So divided by 4 we will get W is equal to 4.25 centimeter per hour. So the W we can check here. W index is always less than phi index. W is 4.25, phi is 4.5 centimeter. So W index is less than phi index. Okay. I hope all of you understood. Thank you.